Welcome to NextLabs Expert Q&A Series. This series was designed to inform you of relevant cybersecurity topics via expert knowledge.
Welcome back to the NextLabs Cybersecurity Expert Series. In this episode, we have our guest, Alex Sharpe, Managing Director of Sharpe 42 LLC, joining us to discuss securing data in the age of AI. Alex, thank you for joining us. Could you start by introducing yourself before we dive into the Q&A?
Sure. Thanks for having me. So, Alex Sharpe, sharp like a knife, there's an E on the end. So I've been in this business for a very long time. I got out of college as an engineer, took a job in the intelligence community, started working on the offense side, and then got moved over to defense and cybersecurity. Along the way, did a lot of work with AI and a few other things. Went into private industry, advising on corporate strategy, process improvement, and the like. Along the way, I ran some business units at some of the larger consulting firms, started a couple of companies, as a founder, successful exits, moved on doing same thing for my own. And now I'm basically independent consulting and advising, mostly to boards, senior leadership, and government policymakers. The lion's share of my work is in two areas: governance of AI. So how do you drive value at reasonable risk without stifling innovation? And then also on resilience, which is really taking cybersecurity and emerging technology to the next level around business value and helping organizations remain viable amidst adversity.
Thank you for your introduction, Alex. To kick things off, what are the security challenges organizations face when deploying AI systems?
The really two biggest challenges with AI overall is that there's a fundamental lack of understanding of how this thing functions and what it is. We still come from a world of, with software, if it was if then else statements, where AI is really you build a vessel and you tell this vessel, I'm going to give you images, and in those images are pictures of owls. You figure out what an owl is, right? It's a very different way of working. It's not those if then else statements. And that fundamental understanding changes. The second thing, I'm going to paraphrase a quote from the former head of DARPA, Defense Advanced Research Projects Administration. Beautiful quote. And it comes down to is that when AI fails, it fails in ways a human never would, right? We have hallucinations. With Gen AI, we create images that just don't work. Heads are turned the wrong way, or too many legs, or not enough arms. This happens. And those are the two fundamental issues. Both are rooted in the data, right? So that's where we see the lion's share in those two problems of fundamental misunderstanding. And then the other one is the nature of the beast and the way they break down when they don't work. And behind all that is how do we control and manage the data that we use to train the models, what we put, how we input, how do we protect anything we upload, and then what do we do with the extracts? Like one of the fundamental problems is who actually owns the intellectual property, right? This is winding through the courts, and we'll see what happens, but we're definitely going to have to figure it out. So those are the core issues, and if you start thinking about it, that starts finding its way with tentacles into pretty much the entire enterprise. Because as we all know, data is the new oil, right? And it drives everything. And that's, so the issues tend to propagate across the entire enterprise in ways we never would have expected.
Those are significant challenges, especially as AI systems become more complex. So how can enterprises protect sensitive data used in AI models without limiting innovation?
There's a couple of sides to that. One of the other things we know when dealing with AI, and it's called AI governance, and I think that is the correct term. A lot of practices we used historically were really about putting controls in place that basically technical controls. And the reality is, because of the nature of these models, those technical controls don't do an adequate job when we try to apply them to AI. So it's really a combination of people, process, technology, and organizational controls, for lack of a better term. to create a program around it. One of the fundamental pieces is the human. And what do I mean by that? Simple, obvious. Because we know things like Gen AI are prone to hallucinations, we need to do our fact checking. All right, we get an output, we need to look at our fact checking, which is very, very important. And the more sensitive and the nature of the use case, that becomes more and more important. We can use models to check on models. We can have third-party teams that are only designed to validate data, right? So that's one part of it. Another part is the agreements you have with the vendors. Clearly delineate who owns the intellectual property, who owns the output, who owns the prompts, who owns the inputs. These are all issues that come up all the time. Also, if you get data, a response that comes out that actually violates somebody else's intellectual property rights, who's responsible? Does the vendor indemnify you for those situations? Right? So those are certain aspects. Probably for this audience, we want to talk about what's commonly referred to as PET, privacy enhancing technology, but it's not just for privacy, right? It goes in a lot of other places. You can take the data and you can tokenize it, right? Which is a fancy way of saying take the sensitive fields and instead of providing the actual data, you provide a representation of that data that can still be acted upon. It's better than encryption from an operational standpoint, but it's not as secure. So secure encryption is incredibly secure when done correctly. But the problem is you're handing something a series of random bits and it can't operate on it. Very common mistake for folks working with like SaaS tools, right? They'll upload encrypted data and say, what I'm getting out is garbage. Well, that's because you're asking it to operate on random data. So with tokens, you can take this field that, oh, with these sets of bits that always means the same thing and it transfers throughout the process without actually disclosing the underlying data. That's incredibly effective. Synthetic data is incredibly effective, especially when training. Synthetic data is just that. Instead of working with real data, like customer data, you have created, using a series of tools and practices, um, something that is close enough. It's effectively as useful as real data without disclosing the real data. Then there's other fancier techniques like zero knowledge systems and the like that tend to be fairly complicated and fairly sophisticated. But for the most part, you really don't need that. You're going to get a lot of mileage over training and awareness. You're going to get a lot of knowledge with having the right agreements in place. You're going to gain a lot of ground and a lot of protection from having the inputs and outputs reviewed. And then also you can augment it with technology. Um, I'm not going to recommend specific products, but there are products out there that are much better than DLP. They will track your AI usage, they'll track prompts, they'll track interactions with different types of models. Right? So they're very, very effective, and actually much more effective than like a traditional DLP. So there are lots and lots of ways to do this. From personal experience, having actually worked with AI for decades, long before it became popular in October of 2022, when ChatGPT, when OpenAI released ChatGPT, these tools and techniques are incredibly effective when implemented. Usually people get in the most amount of trouble when they start looking at technical controls only. Um, that'll get them in trouble. It always does.
Protecting the data itself is essential, but what about the insights AI generates? What best practices exist for ensuring the integrity and confidentiality of AI-generated insights?
Let's talk a bit, because you specifically asked about confidentiality, integrity, and the third leg is availability of the CII triad. So confidentiality is ensuring only, the data only gets exposed to authorized individuals, right? Basically, identity and access management. Integrity is about the quality of data and the operations of the system, where availability, which we're going to put aside for a second, is about the system being viable and being alive. You can actually use it, right? There's an old joke that you could take sensitive information, put it in a cinder block, encase it in concrete, surround it in lead, put guards around it, and it's still not secure. Well, the reality is, if you can't work with it, what's the point, right? It's got to be available. In the world of AI, we talk a lot about confidentiality, with keeping secret secret. What we see more often the case is where organizations get in trouble is integrity. Now, historically, the integrity leg of the triad we usually see in things like fraud and like medical devices, right? Because we that's what's really breaking down at that point. When we deal with AI, it's the integrity of the model. Can we trust the outputs, right? And we know that the nature of the input can really change the nature of the output. We also know that these models, at least the most common ones we tend to deal with, are not deterministic, right? The most popular ones are not deterministic. You can give the same prompt 5 different times and you get 5 different answers. You can have the same prompt injected by 10 people sitting in a row, hitting the return key all at the same time, and you'll get 10 different options, right? So the integrity leg becomes incredibly important. On the confidentiality side, what you're really reliant on is not inputting information you shouldn't into the model. That's primary. You are relying on the human to watch what's coming out and watch what's going in. You are putting agreements in place with the vendors that will guarantee that your data will not be used to train somebody else's model. They will also guarantee that either when told or termination of the processing or termination of the relationship, they will destroy the data. Right. So these are very different techniques than we see in the traditional world when we're trying to protect our data. Another fundamental thing, let's face it, very few organizations are training their own models, right? They're really buying or leasing a model that's been trained by somebody else, and they might tweak it, right? Or it might evolve over time depending on usage. It might learn their own little environments. But in very few cases is a organization large enough or funded enough and have availability of data that they can train their own model. In those cases where they can, or if you are training your own model, one thing that's very important is the cleansing and the safety of the training data. Most of your headaches that you run into are really driven by the training data. So like bias comes from the way the model was trained. That's the kind of thing that gets you in trouble, where there's signs of discrimination in the model, usually comes from the training data. So it's very, very important to do all your cleansing and your cleaning and all that before you use it to train the data. And then you need to secure it away, usually using a digital signature, which not only guarantees the integrity, but also puts a date timestamp on it and preserves it so you can put it off to the side and you can demonstrate at a point in time it has not been altered since that happened. The other key aspect on all this that can't be forgotten about is because we can't inspect the models like we can with software, and the models are forever evolving, right? You inspect a model today, it may not be the one that's in operation tomorrow. It requires a lot around, it's generally referred to as observability, where you're trying to get some transparency, where you are very open to getting reports, vendors, the users, the stakeholders that are around it, the folks that are maintaining the models and working with it every day. If they see odd behavior, right, you can investigate it. You can also monitor for strange behavior. So there's a concept, it's been going around for decades, about process improvement, where you actually take, historically has been called a buoy. You put a buoy into the model and you watch it go through the process from one end to the other. And if it doesn't move through at right rate, velocity, or if the results aren't what you expected, so you're basically testing the model, you sit back and go, ooh, something's not right. Let me investigate it. Right. So it's very important to have those practices in place because we can't inspect the model like we used to, because it's not these if then else statements, because these models are based on the way they're trained and they often come up with strange results. So we have to have processes in place for being open to discovering those, open to taking the feedback, and having a system in place for triaging and correcting. Right? So there's a lot there, but one of the key messages is technical controls alone are no longer sufficient.
Now that we've covered the risks and foundational protections for AI systems and data, in part 2 we'll dive into how organizations can balance business value with data protection, and the emerging technologies that make this possible. Thank you very much for watching and stay tuned to the next part of this episode.